Changing a dimension. Remember, we talked about relationship between scale factor, perimeter, area, and volume. We said that if the scale factor is A to B, then the ratio of perimeter is A to B. Ratio of area is A squared to B squared. Ratio of volumes is A to the third, B to the third. Because area is square unit, volume is cube unit. Remember, similar figure dimensional changes. Height, length, width, radius, diameter, perimeter, circumference can be A. Area of any type of figure is A squared. A volume for any type of figure is A to the third. So if I want to get the height, length, width, radius, diameter, perimeter, or circumference of area, then you're going to do square root of A. That will take you back, working backwards, and it will give you this measurement. If I have the volume, you just do cube root of that scale factor, and it will give you the this measurement A. So you do square root to get this, cube root to get that. Changing a dimension. Number one, if only one dimension changes, so the objects are no longer similar, or if dimensions are changed differently, create your own problem if necessary and solve it. Change it the way described. Analyze how your original answer and your new answer relate. How many times bigger is it? Example, 2 times as big. If smaller, still think how many times smaller, but your answer will be a fraction, half time as big. For example, a cone with the radius 3 feet and the height 10 feet has a volume of 30 pi cubic feet. What is the volume of the cone formed when the following happens to the original cone? Let's say the radius is doubled, right? So this is the volume, third pi r squared h. This is the formula for volume of a cone. 3 is the radius, and then the height is 10. So that will be 3 squared 9 times 10 will be 90 divided by 3, 1/3. That's 30 pi if I don't do the pi. If I double the radius, instead of 3, it's going to be 6, right? So that's 36 times 10 divided by 3, 120. So if I double the radius for this volume, 30 to 120, that is 4 times as big. If I double the height, I get the same thing, 30 pi. But if I double the height, instead of 10, if I use 20, that's 9 times 20. The radius stays the same, just the height is double. That's 60, because that's 180 divided by 3. 60 pi, which is 2 times as big. Another example is the radius of cylinder B is twice the radius of cylinder A. So let's draw. Can you draw A and B and write A and B inside? The height of the cylinder B is half the height of cylinder A. Compare their volumes. So you're going to create your own problem. They don't give you any measurement here. You can actually create it. So I use 5, 10, 10, and 5. So the radius of cylinder B is twice as this. So I just use 5 and 10. You just make up some numbers. You can use 2 and 4, 5 and 10, whatever you want. And then height of cylinder B is half of A. So I'm going to use 10 and 5. So I'm just going to use my volume formula and compute pi r squared h. So pi times 5 squared times 10 is 250 pi. And this one, pi r squared h, 5 squared is 25 times 10. is 500. 10 square is 100 times 5 is 500. And I'm just writing in terms of pi. So the volume of cylinder B is twice the volume of cylinder A. Because you have 250 and 500, it's double. So you need to draw and make up some numbers based on the example. Look at the example. If the height of a rectangular prism is decreased by 1/3, then which statement is true? I got this question from the SOL. So I kind of drew a rectangular prism and it's decreased by 1/3. So I'm going to say the volume will decrease by 1/3, and I can prove it to you by drawing two things. And here you have 6, 3, 4, and then I'm going to decrease the height, which is 6, 1, 4, because 3 divided by 3 is 1. 6 and 4, 6 and 4 stays the same, and you make up these numbers. Everything should stay the same, 6, 4, 6, 4, except the height. And then you're going to do 6 times 3 times 4, which is 72. 6 times 1 times 4, which is 24. So that is 1/3. If you do 72 divided by 3, that's 24. So that's 1/3 as big. So that's one is decreased by from here to here by 1/3. Let's look at the next example. A company is creating a new cylindrical container to replace its original cylindrical container. The new container will have 9 times the volume of the original container. The height of the new container will remain the same as the height of the original container. So I'm going to have you draw these two cylinders and then write volume and volume. And then this is V. This is 9 times V because it's 9 times. Radius, radius. We're going to put some numbers in. So let's say I'm going to make up numbers 10, 10. They have the same height. And let's say this radius is 3. Then the volume for this will be pi r squared h. So that's 3 times 3, 9 times 10, which is 90 pi. And then I don't know the radius for this. So we have to look and say, okay, so 90 pi times 9 times. This will be 9 times of this volume because this volume. So 9 times 90 pi is 810 pi. So 810 pi equals pi r squared h. 10 is the height. We don't know the radius. So pi, I'm just going to cancel the pi. You can just cancel the same thing left and right. And then r squared will be 180 divided by 10, which is 9. So we're going to write r is 81. I mean, r squared is 81. So r is 9 because square root of 81 is 9. So 9 will be the new radius. Then that's 3 times because 3 times 3 is 9. So the answer is 3 times the original radius length. Okay? So you need to make up some numbers and compare like that. So you're making problems actually with numbers that you want to. But you need to follow these. They have the same height. And this blue one is 9 times as this one in volume wise. Okay? Number 2, if all of the dimensions change the same way, so the object stays similar, you can use the relationship between the scale factor and the ratio for area and volume to determine values for the new object. So for example, all of the sides are double. Therefore, the area is increased by a factor of 4. That's 2 squared. The volume is increased by a factor of 8. That's 2 to the 3rd power. For another example, all of the sides are triple. Therefore, the area is increased by a factor of 9, 3 to the 2nd power. The volume is increased by scale at the factor of 27, 3 to the 3rd power. So basically, if your example has, if the sides are doubled, then your area is increased by scale factor of 4 because there are 4 sides. And then the volume is increased by factor of 8 because 2 times 2 squared is 4 and then 2 to the 3rd is 8. If all sides are tripled, then you're going to do area is increased by scale factor of 9 because it's triple, so this 3 to the second power, because 3 times 3 is 9. Because area, you do double it. So right here, if it's double, then 2 times 2, 4, right? And then volume is always cube root, so 2 times 2 times 8. If it's triple, then it's 3 times 3, 9. And then volume is 3 times 3 times 3. The cubic is for the volume. That's 27. So let me show you what I mean by that. So take a look at this example. If I have 30 pi cubic feet for a volume of a cone, if the radius and height is doubled, right, for a volume, then right here, we're going to use, all sides are double, then we're going to use 2 times 2 times 2, which is 8, okay? Scale factor of 8. So what we're going to do is multiply 8 to 30, which is 240 pi. And I can actually prove that to you by why it's 240 pi. Let's say I doubled this, right? 3 times 2 is 6, correct? So it's 6 squared. 10 times 2 is 20. So formula is 1/3 pi r squared h is the volume of a cone. So pi times this divided by 3. So if I do the math here, that part is 720 divided by 3 is 240. So it's actually 8 times, which proves this theory, right? If I double the side, for volume, it's going to be 2 to the third, which is 8, because cube is volume. So you can actually just double it and calculate if you don't remember this. It's the same thing, okay? Let's take a look at another one. If a cylinder has a surface area of 96 square inches, if all dimension of this cylinder are multiplied by half to create the new cylinder, what will be the surface area of a new cylinder? So scale factor is 1/2. So here, instead of doubling, if you cut it in half, then you will divide it by 4 because it's the area. So what you will do is, you will do 94 divided by 4, because we're just cutting in half, which is 24. So 24, just cut this in half, 24 will be the new surface area. So because scale factor is 1 to 2, okay? And then another one, if a rectangular prism has a volume of 36 cubic centimeters, if the height of the prism is triple and the other dimension do not change, what is the volume of the new rectangular prism? So you just do 36 times 3, because height, you have one, let's say you have a prism and you just triple it on top of each other, then you just get 3 more on top. So just multiply 3 to the volume, that's 108. And you can actually do that in length times width times height. If all dimension of the original rectangular prism are triple, what is the volume of the rectangular prism? So you can just triple each length, width, and height, 3L, 3W, 3H, because each dimension is getting triple, which is 3 times 3 times 3, 27. And then just multiply 27 to this is 972, which what we have here, it says if I triple all sides, the scale factor will be 27, because 3 to the third is 27. But if you cannot remember these, I'm just explaining where it's coming from. You can just plug in the new numbers here. Just triple this, and just plug it in. And then that's 27 times 36, which is 972 cubic centimeters, okay? So take a look at those scale factors, and then we can actually see the changing in dimensions.